All right. What's going on there? All right, what code do we have? 43, 45? Is that right?
Yeah.
Oh, it's good now. It's weird. All right. Questions on 3 through 24 is what you're asked to do. 3 through 24, any of those that were assigned. Madison.
12. I was confused on what it was.
12. Yep. That's the weird convert from Riemann sum notation into integral notation. Okay. So in all honesty, there is a way harder next level way to ask these questions that's not going to be on this test for you guys. We are going to review it as we talk about AP test review, but we're not going to overcomplicate these ones. It's actually, once you see what to do, it's going to be, oh yeah, I remember that. And it's not so bad. So 12, was there a bunch of parts to 12? All right, Madison, was there one of them? Do you care which one we do?
No.
How about we do letter, oh, do you guys care? I don't care. C? 12C. 12C, it said the Riemann sum, the summation from k equals 1 to n of c sub k times 3c sub k minus 2 quantity squared times delta x. What is k representing? Not quite. From k equals 1 to n. N was always the number of rectangles, right? These are rectangles. N is the number of rectangles. So k equals 1 tells you you're in the first rectangle. K equals 5, you're in the fifth rectangle. Now, I forget if they asked us to do... Okay, we formed the following Riemann sums, choosing each c sub k in the kth subinterval. All right, we're not going to get way too deep into this. It's not that bad if you kind of break it down. C sub k, ready? Here's the kth, it's hard to say, subinterval. 5th, 10th, 100th, whatever. Here we go. Are we doing LRAM? Are we doing RRAM? Are we doing MRAM? Are we doing I don't care RAM? We're doing I don't care RAM because there's infinitely many of them. It doesn't matter because how wide are these intervals? Really small. So where is C sub k? It doesn't matter where it is on the interval. C sub k, if there's enough of them, turn into x values. Do you follow me? C sub k's, if there's infinitely many of these, C sub k's are turning into x's. So what is this? This function here is really f of x equals x times 3x minus 2 quantity squared. Yes? X times 3x minus 2 quantity squared. That's f of x. That's the function that this came from. Let's keep going. The interval from, these were the directions for 12. The interval from 0 to 10 is partitioned. Okay. So if I'm converting this to an integral, a definite integral, that tells me my bounds, 0 to 10. F of x goes inside. And that delta x, if there's enough of them, turns into dx. That is the integral equivalent of that Riemann sum. That make sense?
Yeah. In the directions, it said something about changing this 0 to 10 divided by 10.
Yes. So they said delta x is 10 over n. What does that mean? How do we find delta x, Cole? Do you remember? Back when we did these?
Was it the length of the rectangle you're using?
Yeah. Yeah, so this came from b minus a over n. Oh, look, b minus a is 10 over n. So if I have a million rectangles, how wide are they? 10 over a million, whatever that is. If I have 10 rectangles, how wide are they? 1 unit each. And then they went on to say, write the limit as n goes to infinity. The limit as n goes to infinity. So now, how wide are these? 10 over infinity. They're infinitely narrow. Those c sub k's just turned into x's because there's so many of them. Good. That was just a write but do not solve. A write it but do not solve it kind of problem. Other questions on the review? Wendy.
You are number 3. I didn't get that.
3. Sketch the rectangles and compute by hand the area for the MRM4 approximation. 3 y equals 4x minus x cubed. All right. 3. M R A M 4. All right. Now, it did say first quadrant in the directions. Did you see that, Wendy? First quadrant? Okay. So this is x times 4x minus x. X times 4 minus x squared. So if I want to find out I want to find the zeros of it to see where I'm looking for in the first quadrant. Well, this is a cubic function. We got -2, we got 0, we got +2. It must be going like that if it's a negative leading coefficient, right? And so this is the shaded region I'm actually looking for. So as soon as I see that, if I know I have 4 rectangles, my delta x is, well, I'm going from 0 to 2. So 2 minus 0 over n, which is 4. Each one is a half. Now, that was not necessary. I bet most of you guys realized you're going to have 0.5, 1, 1.5, and 2. Now, we're not actually plugging any of those in. Because we're doing MRAM, we're going to find our first rectangle is going to be f of 0.25. So ready? Rectangle 1. Base. What's the base of that rectangle, Wendy? 1/2. Good. Times f of 0.25. We're finding the height at 0.25. Rectangle 2 is going to be 1/2 times f of, well, the second rectangle is going to be f of 0.75. Talking about some of you guys. Third one. 1/2 times f of, where are we at now? 1.25. And the fourth, 1/2 times f of 1.75. You with me? And then Wendy, I know, like for that one, when it said by hand, it's gonna get kind of messy. I'm not sure why they asked you to do that. Like, I want you to get this set up. This is the most important part. You guys can have, like, if I give you a calculator, it's gonna be pretty, like, you would be able to do that pretty easily. I hope. Yeah. If I give you a table, be able to do it by hand. Understand what you're looking for. You can't do an MRAM by. You can't do an MRAM if you have a table. You just can't. You don't know the middle. You don't know the heights of the middles. You can only do L and R or a trapezoidal rule. Okay. Does that help? Do you want me to finish it off? Are you good? All right. Other questions through 24? Carly.
24.
24. Was that one? Did you have trouble recognizing the antiderivative of that one, Kylie? I think it went from 1 to e, and it was 1 over x dx.
Yeah.
All right, let's help her out. Whose derivative? Anytime you're looking for an antiderivative, you're asking whose derivative is 1 over x. Do I know it? What is it? ln. It's actually absolute value x plus a constant from 1 to e. Now, did anyone try to rewrite this as x to the negative 1? I probably would have, right? If you try to write it as x to the negative 1 and use the power rule, when you add 1 to the exponent, you get 0, and then you divide by the new exponent, division by 0, that's a problem. That's why this one is a special case, and it came from ln. And remember why I had an absolute value there? Okay, we're going to talk more and more about that in the next chapter. I don't want to spend too long on it right now. But it's on a positive interval, so it didn't actually affect this answer. So you're going to have ln e plus a constant minus ln of 1 plus a constant. What's ln of e? E to what is e? 1. So 1 plus c minus what's ln of 1? E to what is 1? 0. 1 is our answer. Others on that problem set. All right, let's have a bit of work time. Maybe 10 or 15 minutes. That's why I gave you, I know you got mad at me. Homework over the weekend. But I wanted you guys to have time to ask questions. So there's not that many left. I know a couple of them are multi-part, so go ahead and work quickly. If I were you, I'd probably go to the main ones I know I need to ask questions about first. Don't necessarily work in numerical order. Go to the ones you think you're going to need the most help with.
Yes, sir.